With more cars on the street every year, more stringent emission and fuel economy policies are passed to limit its impact on the environment. In order to meet these standards, we must develop new technology and improve the efficiency of our current systems. The University of Michigan's Automotive Engineering Lab houses several projects that do just that. This year, as a part of the Summer Undergraduate Research in Engineering program, I got to participate in one such project.
Hello, my name is Akshay Kinney, and under the mentorship of Mr. John Horde, I worked in collaboration with the Ford Motor Company to reduce EGR cooler fouling and improve the efficiency of diesel engines. Exhaust gas recirculation, or EGR, is a technique by which we reintroduce inner combustion products back into the combustion chamber. Doing so has several advantages.
By recirculating a portion of an engine's exhaust gas, we raise the specific heat capacity, increase ignition delay, lower the adiabatic flame temperature, and thus reduce nitrogen oxide or NOx formation. Apart from reducing harmful emissions, EGR also helps reduce emitted particulate matter and enables advanced forms of combustion such as PCI and HCCI. Since NOx forms at high temperatures, EGR works better if there is a cooler that brings down the exhaust gas temperature before it is reintroduced into the cylinders. The EGR cooler is typically a shell-in-tube type heat exchanger in the EGR circuit. The problem is, however, with time, the effectiveness of the EGR cooler reduces. A process called thermophoresis causes a lot of particle deposition in addition to hydrocarbon condensation. The deposit layer reduces the heat transfer between the coolant and the exhaust gas by acting like an insulator between the cooler wall and the gas. This summer, I worked to improve our understanding of EGR cooler fouling. All experiments were carried out on this visualization rig. It is a specially designed, research-oriented, simulated EGR cooler that was constructed to accommodate both optical and infrared access to the deposit layer. Using this 6.4-liter V8 medium-duty diesel engine to provide the exhaust sample, I investigated the thermal properties of the fouling layer as functions of time and exhaust composition. We manipulated the engine's operating condition and increased the hydrocarbon concentration in the exhaust stream to determine its impact in cooler fouling.
We essentially ran 2 long exposure events, all the while taking measurements and images in situ. We then analyzed the data to study the thickness and conductivity of the fouling layer, and most importantly, to see if there was any indication of stabilization of the EGR cooler efficiency.
I worked closely with PhD candidate James Lee, who will be continuing this research into the fall. I would like to thank him, Ashwin Salvi, Pawan Jagalapudi, and Rajay Raman for all their support. A special thanks to Dan Stiles and Mehdi Abarham and the engineers at the Ford Motor Company. Once again, a big thanks to John Horde and the SURE program for this opportunity. It was a great hands-on research experience that was very applicable to my major in mechanical engineering. I gained a lot of knowledge in automotive engineering and picked up valuable skills such as programming on LabVIEW. Thank you for watching.